It's not the Dutch word for shoe, it's the German word for beautiful.
Okay, that's
But I say shown in the
Okay, it's the last talk of the day, so after this there's drinks, but the drinks will be lasting for an hour, so please stay and ask me questions, and I don't want to have anything rushing you. Yeah, well, we had loads of talks about HTTPS, about CAs, about certificates over the last couple of years. We had talks about CA CERT. We had, well, everybody knows the thing. You need to do HTTPS, but well, the certificate stuff, and you have to go to some mega company and pay money for trust that actually is no trust. So then Mozilla, the EFF and University of Michigan came with this great idea to do a open CA in order to promote the use of HTTPS and promote privacy and prevent eavesdropping. So I really am proud that we have one of the people from the EFF, from the US here to talk about it. So Seth's gonna talk about, well, the Let's Encrypt project and, well, everything around it. And after this, we're all going to use it, right?
Hope so.
Yeah, well, that's...
Maybe some of you are already using it.
Oh, yeah.
Thanks very much.
Yeah.
Can you hear me all right?
Yeah.
It's really nice to be here, so thank you very much. As I was mentioning, and maybe you heard on the microphone, my surname is actually German for beautiful rather than Dutch for shoe. I have different experiences with
I see that part, eventually.
Interpretation when visiting Germany versus Netherlands. Yeah, so I work for the Electronic Frontier Foundation in San Francisco. I guess many of you are familiar with us, but we're a very eclectic organization that works on individual rights. And so we have technologists, and we develop software, and we also have lawyers, we go to court, we have activists, and we talk to legislators and businesses and everybody about individual rights issues. And we're able to work in many different directions and aspects of individual rights issues. So one thing that we care a lot about is cryptography for privacy. And of course, with TLS on the internet, we have a lot of different reasons that people care about the deployment of TLS and different kinds of attacks and different kinds of adversaries that they care about. And we're primarily motivated by privacy and surveillance concerns, but we know that everybody has benefits that they derive from the use of privacy and security technologies. When we've talked to system administrators and companies about our desire that they would protect their internet services with encryption, a very common answer that we used to receive until just a few years ago was, well, that's only for credit card numbers and only for bank account numbers, which is indeed historically why the technology was invented, to protect financial data online. But we found this reply very out of date because as people have used the internet for more and more things, it seemed very clear that there are a lot of things that people do online that they find much more sensitive and much more deserving of protection than a credit card number, which is in fact not particularly secret in the way that people tend to use those today. And so there had been an evolution in the sysadmin world and the internet world where people said, especially after the Firesheep tool was released, that made it very easy to steal people's cookies with a single click and take over social media accounts or GitHub logins or whatever. People said, okay, well, if I have login data, then maybe I need to protect that. But other than that, maybe I don't need to protect anything. And so we've been seeing that network surveillance is very pervasive. It's possible for people to compromise routers. In fact, a lot of routers apparently have been compromised, whether by governments or by other organizations. Large routers, small routers, all sorts of networks are quite easy to monitor, and quite a lot of people are interested in doing it. And networks are attacking us in other ways. So in the United States and elsewhere, we've seen internet service providers tampering with network traffic for a wide variety of reasons, whether commercial reasons or surveillance reasons, or injecting malware, performing injections of content in order to facilitate tracking by, I'm sorry, well, I thought I had another slide about some of the particular attacks that we see from the network with content substitutions. But for example, we saw mobile internet service providers injecting tracking information into people's TCP sessions in order to facilitate tracking of users by the commercial partners of the mobile provider. So your phone company might add something inside your TCP session that you didn't mean to send, so that when you go to a site, that site can recognize who you are, because they've paid the mobile carrier for that ability. And this has happened in the United States, and I've heard when I went to the ITF conference that the US is far from the only country where this happens. And we don't know exactly who does this and where and what all the relationships are, but it's quite a thing. Yep.
What is the business model behind that injection?
I believe the idea is that the consumer of the tracking data would pay the carrier for some kind of demographic information about the subscriber in order to then target advertising or gather statistics about the demographics of site visitors. So you would go to a certain site, and the site would be informed by the carrier that you are subscriber number such and such, which they would say is anonymous because they haven't revealed your name. And then the site would be able to pay the carrier an additional fee to be told demographic data about that subscriber.
And how can I beat up my provider if he's doing that?
So certainly if I said that TLS would completely mitigate that, I would be overselling it and exaggerating the kind of protection that we can get, because it's also possible to deliver that kind of data out of band. But for the one commonly deployed version of this, if the connection were encrypted and authenticated with TLS, the carrier would not be able to inject this data because it would break the integrity check. So we can get a first level of defense with TLS on HTTP sessions to that. Unfortunately, the information can be delivered out of band. So in that case, maybe we need anonymity networks, maybe we need legal remedies, we may need other things in addition to TLS, because the next step may be that the, and I've heard that this technology exists as well, which is very similar to the old ident protocol, that the server operator would come to the carrier and say, which subscriber was responsible for initiating a TCP session from this source address and this source port. So that's unfortunately the next step. But in any case, deploying TLS now, we can get authenticity of connections, and it's important for example, software downloads that people make over the web, even though that information is public. It's important to an extent for reader privacy in what people choose to access on a site and choose to read about, even if that information is public. It's important for preventing content-based censorship of the content of sites, even if that information is public. And then, of course, in all the cases where the information is explicitly confidential, for protecting all of that information. And we appreciate the fact that a lot of the internet world has come to accept the importance of this. Just wondering what happened to that other slide. Here, okay. I have my slides out of order. So this is the slide I wanted to show, right? That we have the reader privacy, we have content-based censorship, we have ad injection, we have tracking header injection. Some service providers and carriers are actually modifying ads to either add advertisements to a web page or to replace the advertisements in a web page with their own ads. That's another thing we can see. And you have location tracking issues, which we read about in some of the Snowden documents, where if you have a cookie, which you intend to be anonymous, someone who was able to observe the network session at one time and identify that user, might then observe that supposedly anonymous cookie at another time on another network and recognize the user even though you can't recognize the user. The network adversary can recognize the user by correlating that with another time that that same cookie was observed. All right, so we talked to people about how we'd like them to turn on HTTPS and other kinds of protection for their network services. And very often in the past they said, well, TLS is very slow. When you want to set up an encrypted connection, it requires a lot of computational resources, it makes things slower. In some data center designs, it's more difficult to integrate because of things like load balancers. A lot of these things have improved quite a bit for various reasons over time, such as faster CPUs and such as hardware cryptography acceleration in the CPUs. One of the complaints that people kept coming back to us with that didn't go away was the difficulty in obtaining and managing certificates. Because if you want to provide encryption on your services and not give people a browser error and not expose them apparently to a man-in-the-middle attack, you need to get one of these certificates, and people found that very annoying. And they would always tell us that they found it very annoying and very frustrating. And we asked some friends who were system administrators to try to complete this process and let us know how long it took. And if these people were sophisticated administrators who weren't very familiar with doing this because they hadn't done it recently, they usually had to go and search for a bunch of SSL commands in someone's guide. And then they would find them and they'd run these SSL commands, and they had to remember which PEM file was which, and make sure that they submitted it in PEM format if that's what the certificate authority wanted. And it tended to always take them an hour, almost independent of the level of expertise of the administrator. I accept people who do this on a regular basis. People who do this on a regular basis obviously have a potential to script it or to become more proficient and not have to look up the documentation every time. But people who are starting from scratch, we found always took an hour. And we said, well, that's kind of frustrating because then it's going to expire and you have to learn how to do it all over again. All right, so we wanted to remedy this by making an automated certificate authority and a certificate authority that wouldn't charge money, because people would also complain, well, why should I pay this money if my organization isn't quite sure the value of HTTPS? Having additionally an annual monetary charge is an additional barrier. And so all three of these organizations, my employer, the EFF, the University of Michigan, and Mozilla, wanted to have an automated CA. And it was a little bit difficult to confirm between all of these organizations that we all had the same idea, because we weren't ready to talk about it publicly, and we had to have some awkward conversations to say, do you have an idea about how to improve internet security? Do you have the same idea that we do? We're not sure we want to tell you what the idea is, but we're wondering if it's the same. And eventually, somehow, we were able to figure out that, in fact, we all had the same idea and joined forces into a single project. And the goal has been, which we've accomplished, to create a completely automated certificate authority that can be invoked or used by a machine to cause the issuance of certificates at no charge to the user very quickly and very conveniently. We have a lot of commercial partners, initially Akamai, Cisco, and IdenTrust. We now have over 24 commercial partners. You can see a list on our website who've made it possible for this to be a service that issues publicly trusted certificates that browsers accept, which was a very important goal for us because we didn't think we'd get a lot of adoption if we couldn't get the browser acceptance. But that didn't necessarily mean that we thought that the existing certificate authority system was perfect. We've actually been quite critical of it and done a number of studies that express a lot of concern about the certificate authority system. But nonetheless, we thought that users would insist on having certificates that work in existing browsers without giving an error. And we have accomplished that. In case you're wondering how we accomplished that, certificate authorities can delegate authority to another certificate authority, issuing what's called an intermediate certificate. So our certificate authority has been approved or endorsed as a CA by an existing authority called IdenTrust. And that's the way that we're able to issue certificates that browsers accept. And the mainstream browsers trust us immediately, The end users don't have to change anything in their browser, or don't have to install an additional certificate. The basic notion is that one of the kinds of validation that certificate authorities can do is called domain validation, or DV, and in this case, just confirming not the identity of the certificate applicant, not the legal personality or business name of the certificate applicant, but just the fact that the certificate applicant does control that particular domain. The certificate applicant, in fact, can be anonymous. And it doesn't matter if they are or aren't, because there's no way we could hope to check their name or where they live or anything like that. We just can check that they control a particular domain on the internet. So it was actually a lot of engineering work to make this happen, but we were able to completely automate this process. And that's an absolute necessity for making this free of charge, because we can't really scale up something that would be free of charge, and that would happen millions of times over and over again, and make that available for no monetary cost, unless it could be completely automated. Yep.
The previous slide, last time, we
Yep.
can replace the certificate authority with a very small shell script.
So that was a joke. There's a common joke that I recall from the Unix world
I will replace you with a small, go away.
or replace you with a very small shell script. That's right.
Now I got the joke. Okay, thank you.
And in fact, it turned out to be a little bit more than a small shell script. It was a considerable engineering task, because we have to satisfy all of these audit requirements and logging requirements and separation of privilege for security reasons. The key point then is not that it's small, but that it is automated. And it doesn't require a human being in the loop to issue the certificate. So we have the certificate authority, which we call Let's Encrypt, and client software, typically running on a user's web server, will connect to the certificate authority. You may be able to get that client software with your operating system. It may ultimately be a part of your web server, which would be really cool. There's one web server called Caddy, which is able to do this. Recently developed web server that's very nice and has a lot of nice features. One of them is that it just gets certificates and deploys them. You don't even have to do any configuration or run a separate program. The web server just goes and gets Let's Encrypt certificates and installs them and turns them on for all of the names that you serve all of the time. It's a pretty cool feature, and we hope that that will inspire other people to have an equivalent level of functionality. In the usual case, this client software is an extra program, and I'll talk about the one that I've been working on and that EFF has been working on. Yep.
How is Caddy spelled?
C-A-D-D-Y.
As the golf in golf.
The person who helps you in the game of golf, that's right. So we have a protocol called ACME, the Automated Certificate Management Environment. There are a number of jokes about the...
that name.
yeah, it's a joke about the Roadrunner cartoons. And we have several other things in this system that are also jokes about the Roadrunner cartoons with the coyote. In particular, the certificate authority software itself is called Boulder, after the rocks that the coyote tried to drop on the Roadrunner. Originally, we were going to call it Anvil, but it turned out there was already certificate authority software with that name, so it became Boulder. But we have these two pieces, the Boulder software, which is open source in case you want to set up a certificate authority of your own. It will be harder for you to have it trusted by browsers, but for example, for internal organizational CAs, we have this open source software that we're developing for people running a CA that speaks this protocol. And additionally, well, let me get to that in a moment about the client software. But the client says, I control these names, and the server says, I'd like you to prove that. And here are challenges. I challenge you to make an observable change in the configuration of the domain to show that the request really did come from someone who controls that domain. And we have three sorts of challenges right now involving the certificate configured on the website, involving the content of the website or involving the DNS records. And then if you can satisfy these challenges, you receive an authorization where the certificate authority says, I agree that indeed you control this domain. And then the authorizations can be used to request a certificate. And then the certificate is issued immediately in a matter of seconds, and then can be downloaded by the client and can be installed. There's an effort to standardize ACME at IETF. It was primarily invented by our colleague Richard Barnes from Mozilla, and there is a working group at IETF that's working on enhancing it. And hopefully it will be published as an RFC. Right now it's in the form of an internet draft. And it handles all of the conversations for domain validation purposes between the client and the certificate authority. So we made a US not-for-profit organization. We received the Web Trust audit, built out infrastructure with data centers, and started issuing certificates last year. And we're already one of the largest public CAs by number of certificates issued, although it's hard to get statistics to figure out our precise rank. I want to go back to an earlier slide that I skipped over here. Oops. Right. I forgot what the title in the program is about how many certs we've issued. But I've been having this problem when speaking at conferences about Let's Encrypt, because I'll always submit a talk and it will say our first million certs or something. Or I'll say in the abstract in the program, we've issued almost 1 million certificates. So at the time that I proposed this talk, I said, well, we've issued almost 1 million certificates. And I had another talk in March where I said our first 1 million certificates. And in each case, as I was waiting after having submitted the talk proposal, we approximately doubled or tripled the number of certificates that we had issued. So it's actually now over 3.5 million as of last Friday.
Good. What did you expect in numbers? Nothing more?
It was hard to know exactly what the demand would be. We obviously hope that lots of people will use this over time and that it will become quite pervasive and routine. The question is essentially how quickly that adoption will come. Whether it's a matter of 90% of internet sites doing this in a month, or whether it's a matter of 40% doing it in 2 years. We have a lot of big ambitions, but it's just difficult for us to forecast the speed with which people will become aware of this and find it useful, and the speed with which it will be integrated with other tools. And that's really where the uncertainty comes from. In this graph, for example, you can see a period of time in which the issuance rate increased very dramatically. Yeah.
Are those new ones? Because they're pretty short-lived certifications.
Yeah, so this is not the number of certificates that are in use, but the number ever issued. Because indeed they're valid only for 90 days. And so some of these are expired. And the number that are currently valid and in use at a given moment is still less than 3 million. But the number ever issued is more than 3.5 million. So that is an important distinction, because indeed over time, eventually most of the certificates that we have issued will have expired, and it won't be very representative of the number of sites that are using our service.
So why do they expire after 90 days?
I'm sorry?
Why do the certificates expire after 90 days?
We chose to have them expire after 90 days, which is one of the most controversial decisions that we've made, alongside not supporting wildcard certificates and delaying support for internationalized domain names and IPv6 only servers. So those are my confessions about things that people are uncomfortable with in terms of our choices. Primarily because we think that revocation doesn't work very well, and we were concerned about the possibility that people would find ways to cause us to issue certificates improperly that they weren't entitled to. So far we have not detected significant incidents like that, but essentially out of caution, because of the large volume and the automation, we said we don't think that revocation really works. So if there's a risk of incidents and problems, we want to have the lifetime of the certs be pretty limited, so that the damage from any particular issuance event, the misissuance event, is shorter.
So
And that's the primary motivation.
anyone doing nasty things has to repeat that every 90 days.
That's right. If someone does something wrong, they would have to be able to do it again in a relatively short time. And hopefully, they'd have to automate their malicious behavior, that's right. Hopefully we would become aware of it and aware of how to stop it in that time. We also wanted to promote automation tools. And there's the benefit of having certificates last for a year or 2 years, that you don't have to do something very often about them. There's also the disadvantage that you don't have to do something very often about them. And therefore you tend to forget how to get certificates. And you tend to not be aware of whether your tools for getting certificates actually work or not. And we had the hope that if we could get good integration at the operating system and server level, people would have a greater awareness of whether their tools actually work for getting and renewing certificates. I think we're partway there on that front.
Makes public pinning public key pinning a bit problematic.
Yeah, the public...
Is there something for integration within the system to allow for public key pinning?
There are some experimental tools for public key pinning. The fact that the public key always changes in the CertBot client, which I will talk about, is actually my fault. I wrote the code that makes it always change. I wrote the code that would make it not change, and then I didn't write a flag to give on the command line to activate that path. Not because I think that people are not entitled to do that, but because I forgot to do it and was doing other stuff. So if your key always changes using CertBot and you can't conveniently use HPKP to activate public key pinning, you can blame me. And there's already an issue in our issue tracker. And I still intend to write a flag to keep the previous key. There are also advantages to changing it. There are advantages and disadvantages, depending on what kinds of threats you're most concerned with. I just wanted to point out there was that very steep slope there, where about 1 million certificates were issued in less than a week, which definitely makes the talk titles go out of date quickly. That was a result of OVH issuing certificates for all of their customers, which was a great thing that they did, and that definitely made the rate of issuance increase quite a bit. It's calmed down a little bit since then.
Who did that?
OVH, the hosting provider. I believe they're based in France. Okay, so just to turn to the client software side, EFF was put in charge originally of writing what we call the official client software, which we wrote in its open source software in Python. It was originally called Let's Encrypt. Eventually it was decided that we wanted to not confuse people about the certificate authority versus the client software and not make them think that they were the same thing. And so we've recently renamed our client software to CertBot. A nice thing that it can do, it's packaged in several operating systems. We'd like it to be packaged in more operating systems. It can modify Apache configuration files. Some people really like that and some people really dislike that, because some people say, I don't want a Python script to edit my Apache config, I want to do that myself. Other people say, I don't know what an Apache config is, and I really like that this program is somehow able to make the cert appear on my website. That's great. So you can use either, you can let it edit your Apache configuration or not. Commonly, it is able to finish the whole process in about a minute. And I'd like to try to give a demo, being aware that live demos come with some risk, that I may have not done something properly. But let me try to give you a live demo of what this could look like. And I'll also bring up a browser just to show the consequence here. Yeah. I think
the HTTPS.
I was going to do HTTP and HTTPS. This is a site that currently I deleted the old cert about 5 minutes before my talk, so that HTTPS is not turned on this site. Unfortunately, the SOX proxy that I was using, I think the NAT on this network has timed out, so I'm not able to do anything on the network. So I have to since I have to restart my SOX proxy, I think I'm going to go through my slides and then try to do the demo at the end. because that's going to take an extra minute, and I don't want to make everyone watch me do stuff that you can't see for a couple of minutes. But I do still plan to do a demo, all right?
We love that.
So, okay. One thing that we don't have working quite yet is Nginx integration, and there's a lot of requests for that, and we're working on it.
What's the situation with Windows? I'm still got
Yeah, there is, someone else has written a Windows client. It's not quite as mature, but a lot of people have been able to get it to work. I can show a pointer to that. So we've definitely focused on Unix-like systems writing in Python, and primarily testing on Linux, but people have gotten it to work on OS X. And I assume that it would, in principle, work. Some people have gotten it to work on BSDs. There have been some problems with some of the Python library dependencies, that on some of the BSDs, some of those dependencies can be difficult to compile. But we have had success reports from OS X and some of the BSDs. Yeah.
How about usage of TLS with IMAP and SMTP?
Yeah. So we would like to add plugins for this. We have a plugin architecture to configure other kinds of servers apart from web servers.
Yes.
The issuance process is relying on either a DNS record or HTTP or HTTPS listeners, just to confirm control of the domain. But the certificate that you get is not specific to a particular protocol and can be installed, for example, in an IMAP server to authenticate that IMAP server.
But the name has to match. So.
Yeah, so on a machine that name points to, you would have to be able to run a web server. If you're not running one full-time, CertBot has something called standalone mode, where it can bring up a web listener for a few seconds to satisfy the challenge and then shut it down, which is one option in that case. If you did have a web server on the same machine, you can also use something called the web root mode, where you tell it where the web documents are stored for that web server, and it can create a file temporarily to prove your control, again, of that domain. And then when you get the certificate, you don't have to install it in the web server, but you could install it in the IMAP server or other TLS server. We definitely want to write more plugins so that if you want CertBot to edit, for example, the IMAP server configuration, it should be able to do that in the future. Yeah?
Are you considering DNSSEC validation to the whole domain validation process?
So there is someone's tool, if you want to make DANE records that describe the cert or key that you got using our tools. We haven't integrated that yet, but I think we will. So that you would get, you're thinking the other direction. Using DNSSEC to check on the issuance. You mean?
Yes, Let's Encrypt uses DNSSEC validation to indeed prove you have control over the domain.
So I believe that the verifier that we use will enforce DNSSEC checks if DNSSEC is turned on for a particular domain.
Yes.
So I believe that if you have DNSSEC on your name, then whatever A record we use when deciding where to connect, or the text records that you can post to cause issuance would have their DNSSEC signature checked already. So I think in that sense that is in place.
Yeah, okay, cool.
I'd like to double check that, but I think that's the case. But then if you wanted to then publish a DANE record with DNSSEC to say, this is the certificate that you should expect when you connect to this service, there is a third-party tool to generate that, and I hope that that will be integrated in some form into CertBot so that you can run something and be told what that record would be. Yeah?
As a matter of curiosity, can you say how many DNS01 requests there are in comparison to web requests?
I don't know that number. The question is about the different validation methods that we offer and how prevalent each one is in terms of the actual use. I think on the Let's Encrypt stats page, we have statistics about that, and at the end I can try to take a look at that. It's the https://let'sencrypt.org/stats, and I believe that's one of the graphs that we have.
Is it the case that you only have to use one of those authentication methods?
That's right. Any one of the 3 authentication methods is accepted. So it's meant to be for the convenience of the person getting the certificate. For some people, one of these is much more convenient than another, depending on your situation.
I'd expect that you require DNS and something on the web server, so that if either the DNS server or the web server is compromised, that someone can't issue a certificate.
Currently not. I know that that seems kind of scary. It is in line with the practices of other certificate authorities. That one validation method is regarded as sufficient by itself. I'll get to the sort of scariness of the system soon. Another scary thing is parsing configuration files. My boss told me that in some sense Apache configuration files are already Turing complete. They're able to perform in some sense arbitrary computations. So we can't expect to be fully correct then in parsing them to decide whether a certain thing is included or whether a certain redirect is occurring. Because we would need to be able to solve arbitrary computational problems to do so. So if you're designing a configuration file format in the future, please don't make it that powerful. It's really not a security benefit or an automation benefit to do so. Configuration file formats should be parsable by machine. That's really the ideal. And we really had to struggle because they're, in many cases, not parsable by machine in the general case. Since we have an open protocol, there are about 20 now Let's Encrypt clients that you can use. For example, Acme Tool and Acme Tiny are simple ones that are quite popular and simpler than CertBot that don't attempt to install the certificate for you. And there is at least one implementation on Windows with the ability to deploy to Microsoft IIS on the server side. And different people use certificates in different ways, and we're quite happy about this. And I give the example of Caddy, the web server that really automates the process to the extent that it doesn't even really ask you. It just says, you have a Let's Encrypt cert on this domain because you asked me to serve that domain. One of the things that we've been very nervous about with the certificate authority system is that the level of checking that certificate authorities do, in some sense, is very small or very fragile. That if someone is able to take over or spoof something, they may be able to get a certificate in a particular name. There's also a lot of concern that governments might be able to either get people to hack certificate authorities, I know many of you may have heard of such cases, or perhaps compel certificate authorities to issue fake certificates. Of that, we don't really have detailed public proof, but it's definitely something that people have been concerned about. So all of these things are forms of fragility of the system. Spoofing the validation or verification of domain control, government-compelled misissuance, or hacking of CAs. And all of those things would be very bad in terms of the cryptographic attacks that they would enable. So one of the main things that we do is that every certificate that we issue, we publish in Google's certificate transparency system in a place outside of our own control. If you ever found a certificate that we issued that's not published there, something is very wrong and you should complain and criticize us and let everyone in the world know about it. It's very improper. No one has ever found such a thing, and our intention and the way that we've written our code is to automatically publish all of these things the very moment that we issue them, so you can go and look and see what certificates we've issued and whether you agree that they should exist and that they're correct. And I think that's a great system, and there are more ways that it can be used more automatically. But we'd like to see other certificate authorities adopt that as well. And again, that's outside of our control. It's not just publishing them on our website, it's publishing them in someone else's log. And there's also a method called CIA in VNS, where if you don't like us or don't trust us and don't want us to issue certificates for you, you can make a CIA record and tell Let's Encrypt not to issue certificates for your domain. And now, since that's only in DNS, if someone is able to take over your DNS server, they can remove that record. But for non-DNS related attacks, that's a way to say, I don't care to have Let's Encrypt issue for my domain. We would really like to see Let's Encrypt be integrated in more places. We have, as I said, CertBot is packaged in a number of operating systems, and we're happy about that. WordPress.com is automatically getting a Let's Encrypt certificate now for all of their users. OVH is, I believe, getting a certificate for every single web hosting customer on OVH. We'd love to see more people doing things like this automatically, so that HTTPS just becomes a really routine feature. And we've heard from a number of other providers who are interested in doing things like that. So if you are involved with some kind of server software and you think there's some way that you could make it more convenient for people to integrate or deploy these certs, we'd be happy to talk to you or just have you do it yourself using our open protocol. Yeah?
I've read somewhere that Synology also, it's now also included on the Synology loss systems.
That would be great. I was not actually aware of that. On our forum a couple of months ago, people were asking how to configure these with Synology. And at that time, I didn't know what the answer was. But a number of companies have sort of gone off and written their own plugins and tools, and we think that's exactly what we want to see them doing. So that's great news, just to have more integration. Some of the people who develop control panel software of various kinds for web hosting have also been either getting contributed plugins or writing their own plugins. And you, again, you don't need to use CertBot to get the certs, right? You can just implement an Acme client, get the certs, and deploy them in whatever you'd like. I'd still like to, if I have the time, attempt the demo.
Yeah.
But that's all I've got in terms of the slides. So thanks a lot. Let me...
Before we all, after the demo, go for a drink, please fill in your evaluation forms and drop them at the desk, so we know what you think about the talks, conferences, and everything, and the demo.
Okay, so I started a... Okay, so here's a root shell on a web server somewhere in the world. And I'm also going to bring up a web browser. And now I want to look at example1.loyalty.org.
Was it a typo?
Or .org. Thank you. Okay. So this is an example site, and here I've gone to the non-secure, non-HTTPS version of the site. And hopefully before the demo, I made it so it doesn't have HTTPS, right? I had to undo it because I gave this demo a few days ago and had HTTPS then. So this is a typical error that you see when you're trying to go to a site in HTTPS and it doesn't work. There are, of course, many other browser errors depending on the exact reason that it doesn't work, like expired certificate or unknown certificate authority, or a name mismatch, or incorrect cipher sweep, and quite a few others. But here's one. In this case, this is the error that you get when it's serving HTTP on port 443. Various reasons that Apache might default to that in some configurations. Okay, so what I want to do now is enable HTTPS here. So I have my root shell on the web server, and I'm going to run certbot. The way that I installed it here, all right, hang on. It's a little bit hard for me to do this backwards. Okay. The way that I've installed it, because I didn't use the OS package because I'm developing on this, I just have the current version from Git. Most people would use apt-get install and they would have it. Let me make this a little bit bigger. Yeah. So what it's done is it's parsed my Apache configuration and seen the various virtual hosts that I have. On this particular machine, I have 4 virtual hosts, so it detected those. And so then it asks me whether I want them in my certificate. And I'm going to, in this case, turn off all of them except, for example, one.loyalty.org. You can, of course, get certificates for multiple names, up to 100 names. And those certificates, the certificate will include all of the names as so-called subject alternative names. But in this case, I only want the one certificate, for example, one.loyalty.org, so I've turned off the other ones. And it's now communicating with the certificate authority and answering challenges to prove that I control that name. Some sort of challenge, it's making changes in Apache and making it do the right thing to prove that I control it. And then the question is, do I want to redirect HTTP to HTTPS or not? So I'll say, yes, I do want to redirect everyone to the secure version of the site. And it says that it worked and it's done. So let's go back to the web browser. And if I load that, it now comes up in HTTPS with a new cert that was just issued right now from Let's Encrypt. Yeah, so it was issued by Let's Encrypt right now, and then it was deployed on that site, and so we made an HTTPS connection to it. So clearly people have a wide variety of server configurations, and not every person will have that kind of experience, but I thought that was pretty fast. It's about 30 seconds, and we run one command, and we get HTTPS turned on the site. And that was our basic vision for what we wanted to get to, and I think we've gotten there. So I'm grateful to all of our colleagues who did the bits and pieces, and we're now at least in that position. Yeah?
Is there someone who lends a laser pointer to Marijn Brandt?
Ja.
Yeah? You can pick it up at Debbie.
Ja,
Okay.
ik weet dat hij het uitbrengt, dus you can pick it up.
Thanks.
Okay.
Was there another?
Yeah.
I know the time is pretty short before the drinks, so try to go through questions.
There's enough. There's enough.
Okay. Try to go through whatever questions people have. Yeah.
In the prompt, I did recognize a address on private range.
Oh, that is on, it's in the Amazon AWS, just the way that it's hosted.
On the inside, behind.
It's behind a firewall, but in fact, this site, if you go to this yourself, this site is a public site on the public internet. It's just that because of Amazon's hosting design, sites don't need to know their public IP address. So the server doesn't know its public IP address, which is why you saw the private address referred to. It's just an artifact of the hosting mechanism.
That it's so fast. Where is the encryption magic done?
There was actually a connection between one data center in the United States where the certificate authority is based and another data center where my web server is hosted. There was a connection, and HTTP round trip to confirm that the change was made that the certificate authority requested. That happened while we were waiting when I pressed enter in CertBot.
My question once again, the generation of the private key, where did it happen?
The private key was generated on my web server.
Okay.
When I ran CertBot, one of the things that CertBot did was to generate a new private key pair. I can, if I actually show you the contents of the file, I'm required by the terms of service to revoke the cert, but
Show the date. No. The point is, Let's Encrypt does not know what the private key is.
that's right, the certificate authority doesn't have it.
Okay, nice, thank you.
So it's going to be this file privkey.pem on the server, and that was created just now. That's not in this time zone, I suppose, but it was just made just now. And it's just on that server.
Thank you.
Okay, the other questions, good.
You have plans to expand the system to issue
So there are other uses of certificates, such as code signing and client certificates and email for S-MIME. We're not sure that we know how to do those kinds of validation appropriately. So we don't currently have a plan for issuing any other kind of certificate. I can see that there would be value in automated issuance of certificates for S-MIME. I would say we don't feel that we have the design for it or the operational experience for it as yet. So we have not begun work in that area. It is a possible area that we could explore in the future.
If I compare your efforts with J.H.A, which is a completely different organization, they haven't managed to get accepted certificate in 5-6 years. You did it all way, you didn't become a complete free J.H.A organization because of the intermediate certificate. Could you at least compare the two? Because I see a result which is much more usable from in such a short period.
So a lot of people have wondered about the similarities and differences between us and CA-Cert. I don't want to speak for CA-Cert because I'm not a part of it and I don't know exactly what the problems they've encountered are or why they do things as they do. My impression in general is that CA-Cert has tried to be a much more decentralized, community-based organization. And that organizational model has been harder for the existing industry to feel comfortable with, even though it has a lot to recommend it in other ways, but that the industry may have been kind of uncomfortable with the level of decentralization and the level of community management that CA-Cert has. And what we've created is indeed a lot more centralized and a lot more sort of in the image of the existing certificate authorities, with the notable difference that we are not-for-profit and don't charge money. But organizationally, we have much the same structure and much the same practices as existing corporate CAs. And perhaps that's something that was easier for the industry to be willing to deal with. But we're not necessarily great fans of centralization and hierarchy, but...
personally, I would say their checks are a lot stronger than yours. But I don't get a recognized certificate. That's what bothering me.
Well, I don't know how to account for all of those things.
So, on your first slides, you said that the aim was to provide a more the CA that is easier and cheaper, but also more secure. So I can see that it's cheaper and easier, but have you also succeeded in making it more secure than a traditional CA? Because I don't.
So we have some check mechanisms that we were aspiring to do that we haven't deployed. Some of those may yet be deployed, and that may give us an advantage over some other people's domain verification. I would say the principal security advantage that we have today is our embrace of certificate transparency, which not all certificate authorities have done. So we've made it easier to catch us if we make a mistake, and we've made it harder for us to get away with things. We're certainly not the only authority that uses certificate transparency, but in the DV world, it's still relatively uncommon, though becoming more common. In the EV world, it's quite ubiquitous now. But we're not so many DV authorities use certificate transparency, and we do. There are other kinds of checks and precautions and transparency that we've aspired to adopt that we may still need to. The one example that I can mention is that we plan to do the domain validation from multiple points on the internet to increase the difficulty of doing DNS spoofing or BGP attacks to spoof the validation. So we'd like to do the checks from several different countries, from multiple autonomous systems on the internet, so that if someone is able to do, for example, a BGP routing attack against part of the internet, but not all of it, then that would not fool us. And we have work underway in that direction, but we don't have that deployed live.
Actually, I work for a net service provider, so we would help you out with the adding tools.
Could be interesting. I think we have been interested also in getting BGP monitoring data feeds and using them in a risk assessment. Not something that we've deployed either to date.
Last question?
Boulder, is that the validation API, or is it also the certificate authority or something?
Boulder includes all of those elements. It includes the validation authority, the registration authority, the certification authority, all of those components. There are some system administration scripts and the internal code in the HSM itself that we don't have in that software distribution, but all of the other elements that we run in the data center, and I guess our firewall rules, again, are not there. All of the other elements, to my knowledge, that we run in the data center for every component of the service is the open source code in Boulder. So it should be fairly complete for some kinds of certificate authority operations for people to adopt and contribute to.
Okay, thank you.